Welcome to this poster video object. This work is titled A Metaphor-Based Technical Framework for Musical Sonification in Movement Rehabilitation. In recent years, the potential of sonified feedback in motor rehabilitation has been increasingly explored with interesting results. In general, a key challenge that has to be tackled is that of mapping design, for which there haven't been specific guidelines as such. Also, the use of musical sonification is gaining popularity. So the general idea here is that there is a patient carrying out a specific movement task, and there's a system that captures the movements of the patient, computes task-relevant features of this movement, and sonifies them in the form of music. Ideally, this feedback supplements the intrinsic feedback mechanisms that the patient already has, such as proprioception, in a manner that enhances motor learning. A couple of key problems here are that firstly, designing meaningful mappings is a complex process that needs to be very application specific and often user driven. And secondly, the aesthetic qualities of sonifications in general are very, very important if these sonifications have to be used for long periods of time. So the aesthetics issue is something that can be addressed by using music as a sonification medium. And one way of tackling the meaningfulness issue is to approach sonification design as the design of metaphors that connect movement to sound. So a metaphor is something that we use to understand an abstract domain in terms of a familiar one. For example, the expression that love is a journey. Similarly, we can use our existing embodied knowledge of sound and music to understand the relatively abstract domain of movement kinematics. But for this to be possible, the mapping between kinematics and sound needs to be designed in a way that facilitates this association. Now the challenge is, how do we define suitable metaphorical mappings for a specific rehabilitative application? The answer is a technological system built for embodied mapping exploration, which is what the present work is about. Our system is built on a set of metaphors that connect the physical kinematics domain to the sonic domain. More information about these metaphors can be found in our paper. So in short, the system that we have built comprises motion capture using inertial sensors, a software application for real-time mapping control, and the sonification is achieved using physical modeling-based multi-track music synthesis with 4 or 5 different instruments that are simulated. The mapping control itself is GUI-based and allows precise manipulation of mapping specifics between movement and music in real time. So the advantages of our framework are its flexibility, scalability in terms of metaphors and mappings, and also the diversity of mappings that is afforded to us by the GUI interface. However, a pre-scripted GUI such as ours cannot cover every possible mapping. And another thing is that we have not tested on any specific target group to validate the metaphors and mappings that we've designed, such as the demos that you just saw. But however, we are using this framework to design and test mappings for a set of applications, including the sit-to-stand transition, as well as walking and knee exercises. So if you're interested in more technical details of our system, as well as links to other sound demos, then they can be found in our paper, along with a link to our GitHub repository. And thank you very much for watching.